All right, for section 8.4, we are looking at solving with square roots. So we're still looking at quadratics, and by that I mean we are still looking at equations that have an x squared in them, but we're going to be able to solve those using our square roots. So first, let's look at a quadratic equation that looks something like this. X squared minus some number c equals 0. We can solve something like this if we get x squared alone. How to do that is we'd have to add that value c to both sides. When we do that, that cancels out over here and just leaves it on this side. So we have x squared equals c, as you can see over here. Once we've got that x squared term alone, to undo a squared, you have to take the square root. So we'd be taking the square root of both sides here. Square root on this side, square root on this side. This square root of x squared, the squared and square root cancel out, so we just have x alone, and then we'd have the square root of c left over. So when we take the square root, we'd get two answers, one that is positive and one that is negative. And why that is because let's say we were looking for the square root of 9. That means what number times itself makes 9? Well, 3 times 3 makes 9, but also negative 3 times negative 3. Sorry, that should be a times. Negative 3 times negative 3 would make positive 9 as well. So there's always two answers. One is positive and one is negative. So as you can see here, we'd have x equals square root of c and x equals the negative square root of c. And you can write that as this positive or negative, plus over the minus. So x equals positive or negative square root of c. That's how you would solve something that started out as x squared minus c equals 0. So, for example, we're going to solve the following two quadratic equation. X squared minus 4 equals 0 and x squared minus 25 equals 0. So let's look at the first one. X squared minus 4 equals 0. To get rid of this c value, this time it's 4, we're adding 4 to both sides. Add 4 and add 4. These will cancel out, and that leaves us with x squared equals 4. Now to get x alone, we take the square root of both sides. Square root on this side, square root on this side. Square root of a square will cancel out, so we don't have this and we don't have the square root anymore. And then the square root of 4 means that we have two answers. The positive square root of 4, as seen right here, and the negative square root of 4, as seen right here. Which means in the end our answers are 2 and negative 2. Those are the two possible solutions for this original equation. And to prove it to you, let's plug these in. 2 squared is 4, minus 4 equals 0. Okay, so that one works. Negative 2 squared means negative 2 times negative 2, which equals 4, and 4 minus 4 equals 0. So this answer works as well. Let's look at our next example here. We've got b, x squared minus 25 equals 0. Again, we're going to add 25. I'm going to write that above here. Add 25 to both sides of our equation. When we do that, it now looks something like this. We've got, there was the plus 25 and the plus 25. It now looks like x squared equals 25. We're going to take the square root of both sides then. Well, this is supposed to be square root of x squared. Okay, this squared and this square root cancel out, meaning that x equals the square root of 25. Remember, there's a positive value and a negative value. Square root of 25 is 5, so x equals 5, and x equals negative 5. So, let's look at examples of problems that are a little bit bigger than this. We first off always need to get x squared alone. We're always trying to isolate that x squared value. So in this one, we've got x squared being multiplied by 4. So the first thing we need to do is divide both sides of the equation by 4. When we do that, it now becomes x squared equals 25. Next thing we need to do to both sides of the equation is take the square root. Taking the square root of both sides leaves us with x equals square root of 25. Remember, this is positive or negative. There's two answers with that. So if x equals the positive or negative square root of 25, that means x could either be positive 5 or x could be negative 5. These are our two possible solutions for this equation. Let's look at another example. We've got our x squared value here. It's being multiplied by a number, 0.5 to be exact. It's also being added with this number 3. So, to undo the equation one step at a time, the first thing we need to do is subtract 3 from both sides of the equation. When we do that, we're left with 0.5 times x squared equals 8. These two canceled out. 11 minus 3 equals 8. Now, to isolate our x squared term, we need to divide both sides by 0.5. Right now, our x squared is being multiplied by 0.5, so we divide both sides by 0.5, and we get x squared equals 16. Now, to get x alone, as before, we take the square root of both sides, leaving us with x equals the square root of 16. Again, don't forget that this can be positive or negative. There's always two solutions. Positive square root of 16 would be 4. The negative square root of 16 would be negative 4. So our two solutions are x equals 4 and x equals negative 4. Another example. Here we have 2 times x squared plus 17 equals 17. First thing we want to do is subtract 17 from both sides of the equation. When we do that, we're left with 2x squared equals 0. To get our x squared term all alone, we need to divide both sides by 2. In doing so, we get x squared equals 0. To get that x term all alone, we need to take the square root of both sides. We'd be left with x equals the square root of 0. Now, like before, it's still positive or negative. There's always two answers here. But in the end, our answer would be positive 0 or negative 0, and those are not different from each other. Positive 0 is the exact same as negative 0. So in this case, there's only one solution, and it's just simply x equals 0. Here we have a much larger equation. We have x minus 4 is inside the parentheses, and that is what's being squared. Then take that and multiply it by 5. Then take all of that and subtract 45. So to simplify this problem, we're going to pretend that this piece, this x minus 4, what if we just called that y? Then it would look something like this. 5 times y squared, so y squared and then times 5, minus 45 equals 0. Now this looks a lot like one of our other problems. So we're going to pretend for a second that x minus 4 is the same as this term. We're going to call it y. So how to solve it if it were to look like this? We would add 45 to both sides. When we do that, it would now say 5 times y squared equals positive 45. Next thing we'd have to do is divide by 5. Again, when we do so, we're going to be left with y to the power of 2, or y squared equals 9. Next step is to take the square root of both sides. When we do that, we get y equals the square root of 9. Don't forget that would be positive or negative. And in the end then, that means that y would be 3 or negative 3. Those would be our two possible solutions for y. Remember though, y isn't actually y. Y means x minus 4. So we're going to do the same steps that we did here, treating it like y, with this x minus 4. So here we go. We're starting off with our first kind of normal original equation. We're going to add 45 to both sides, just like we did over here. So it matches up the same. Divide both sides by 5. Again, everywhere we see y over here, we're keeping it as this x minus 4 because that was the original piece. Take the square root of both sides, just like we did over here, and we get x minus 4 equals the square root of 9. Remember, that can be positive or negative. So we get x minus 4, that was this whole piece, equals either 3 or it could be negative 3. Now, once we're at this point, we have x minus 4 equals either 3 or negative 3, but we want x alone. To get x alone, we need to add 4. Adding 4 to that x minus 4 just leaves x. So x is alone on this side now. Over here, though, if we had positive 3 plus 4, that would give us 7. If we had negative 3 plus 4, that would give us positive 1. So in the end, these are our two solutions. X could either be 7 or x could be 1, and that would solve this equation. All right, in a similar way, we're going to solve this equation. 41 minus x plus 6 quantity, this whole thing, squared. We're treating this binomial, because it's this thing to a power of 2, we're treating this as its own number. Think of it as a y or an x, its own little variable. So you can almost think of it as 41 minus y squared equals 5. So the first thing we want to do to both sides is subtract 41. We want to get rid of that piece. When we do that, we still have this minus in front of the x plus 6. Think of it as like a minus 1 or negative 1 being multiplied here. So we have negative x plus 6 squared equals negative 36, because 5 minus 41 is negative 36. How do we get rid of this negative sign in front of both of these? Well, we would divide by negative 1. When you divide by negative 1, really all it does is change the signs. So this becomes positive, this becomes positive, and we now have x plus 6, all of that to the power of 2 equals positive 36. Now, to get our x plus 6 piece alone, we take the square root of both sides. That'll cancel this out, and it'll give us a square root over here. So we're now left with x plus 6 equals square root of 36. And remember, it can be positive or negative. There's always going to be those two different forms of it. Again, we want our x to be alone, so we're going to subtract 6 from both sides. I'm going to write it this way. I'm going to start with that subtract 6 or minus 6, and then say either plus or minus the square root of 36. This now becomes like a starting point, negative 6. Add square root of 36 or subtract square root of 36. So it's going to look something like this. Here was that minus 6 that I did right here to get rid of it on this side. We're calling it negative 6 because it's minus 6. Either we can do plus the square root of 36 or minus the square root of 36. And remember, the square root of 36 is 6. So we have negative 6 plus 6 or negative 6 minus 6. Now, if it was negative 6 plus 6, then we would say that x equals 0. If it was negative 6 minus 6, we would have x equals negative 12. So 0 and negative 12 are the two solutions for this equation. And that'll wrap it up for 8.4.